Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, isomorphic strings. So we have two strings S and T, and we want to determine if they are isomorphic. And basically by isomorphic, they mean you can replace the characters in S to get T. Right? So you can take, for example, in this first example, you can take E, replace it with A, G, replace it with D in both places, and then you get T, right? So that's what we want to do. There is another constraint is that all occurrences of a character must be replaced with another character while preserving the order. So you can't switch the order, and then you can't have two characters mapped to the same character, okay? So, for example, here, O, you can't have A and R mapped to O, okay? That's what this, so this one is not possible, okay? So that's the idea, and if you look at the time, at the length here, it's quite big. So let's see how we can tackle it. Okay, so the first thing we need to do is understand a little bit what the problem is asking. So for example, let's say we have the first example here, where we have egg and add, okay? So first, let's do the mapping of S to T. So we can map E to D to A, and then J to D. And then the second one, the mapping, we just replace because J maps to D. Okay, so we replaced E with A, J with D. Okay, and we make S equal to T. And so this one works, but let's change this example a little bit and have K here. Now, in this case, we would have A mapping to A, still same thing, and then J mapping to D, and then K mapping to D. Okay, now all still fine. No two characters of S map to the. Now this doesn't work because two characters of S map to the same letter of D, which violates the condition that we have in the description, which says no two characters map to the same character. Okay, so we already determined that this is wrong. Okay, now let's take another, a little bit of a tricky example. Another one, paper, and title. Okay, so this would be S, this would be T. So we'd map P to T, A to I. P, we'll see it's already mapped to T, so we are fine. No contradiction here. E maps to L, and then R maps to E. Okay. So fine here, no two letters map to the same character, right? P, one character, T, which nothing else maps to it, A, I, nothing else mapped to it, E, L, nothing else mapped to it, R, E, nothing else mapped to it. Okay, even though, notice something here, even though you have E on two sides in two different places, right? But this is fine because it still maps to different characters. Here, E in S maps to L, and the other one, R in S maps to E in T. So it's different directions, right? I want to note that there. Now, if you take a look at even another example, B, A, D, C, this is S, and this is T. Now for this one, let's see here. Now for this one, well, B maps to B, that's fine. A maps to A, so still the same. D maps to B. Okay, and then D maps to, C maps to A. So now we have a problem because we have two different letters, B and D, mapping to the same letters. Actually, it may have been more clear for me to just say something like this. Okay, so D maps to B. Okay, so now you can see two different letters map to the same letter in T. Okay, so this one we should return false. We should return false. Okay, now how do we implement this? Well, the first thing, just for this, what we can do, what if we have a map, right? What if we have just a hash map where we can just say, for example, here, M map, where we have, first we say A maps to A, G maps to D, and then C maps to D. Okay, so now we have a problem because we have two different letters mapped to the same character. So G maps to D, and then K maps to D. Okay. So this is, we can check, we can find the problem is the key here doesn't exist, so we can still map it. So this won't be, this alone is not enough for us to detect. Okay. It may be enough, it may be helpful for us if, let's say, maybe we had, let's say, egg like this in S and A, DB maybe. Yeah, ADB, for example. Now, in this case, we will have in our map, we will have E maps to A, G maps to D, and then G also maps to B, but we already have a different value, a different mapping for G, so we will say this is false. So for a case like this, a map for S will help us. A map for S to T will help us. So we still need that one, okay? But for this one, it's not able to detect it. So how do we do it? Well, the problem here, if we notice what we are lacking, is that it's the same letter in T that maps to different letters in S, right? So let's just do a mapping for T to S in the different direction to be able to get it. And so let's do just a mapping. So let's just take this one and do a mapping for T. So that would be, say, A maps to E, D maps to J, but then when we encounter D again, we'll find that now it maps to K, which is different than this one. And so we'll say this doesn't match, so forth. Okay, and this will, you can try that example with this one and with this one, and you will see both, this will return true, this will return false. But that's the core idea. We'll use two mapping because one is not enough. We'll use one for the characters from S to T. And then if we find a contradiction like here, like we did find here, we'll return false. And then another one for T to S, if we find a contradiction, we'll return false. That will handle all cases for us. And yeah, that's pretty much it. So let's try it. Okay, so we said we need two maps. We need one for S and we need one for T. Let's have them like this. And then we need to just go through the letters for both. So let's call one S the character, let's just have the index, right? Because we are guaranteed that they are the same length here, okay? So what we need to do here is get the range, length of S, okay? And we check if SI is, now we know that we want to save the mapping for S to T, okay? So this is basically the mapping, the first direction. And then the second direction, which needs to be T to S, it's going to be mapping T. Actually, it may be easier to just say this is S to T, and this is 2 to S. Okay, so S to T, T to S. Okay, this way it's super clear. Now we will check if the character in S already exists. Okay, we want to make sure that there is no contradiction, which basically means if a contradiction means basically the mapping doesn't confirm with the current letter mapping, then we return false, right? And so if the S to T of S of I is different than T of I at this position, that means we have a contradiction, and so we return false. And similarly in the other direction, we want to check the same thing. So we say if T of I, and this time it's T to S, the other direction, and this would need to be T, it needs to be S of I, return false. Okay, now if we go through all of them and we don't find any issues, we return true, right? It means they are isomorph. We can submit and that gets accepted. Okay, now in terms of time complexity, this is going to be O(n), right? Because both have the same length, and so let's assume their length is n. It's going to be O(n). Time, we are using these two maps, which will be O(n) space as well. Yeah, and that's pretty much it for this problem. Thanks for watching and see you in the next one. Bye.